let's look at binomial coefficients. We've gone over binomials with Pascal's triangle, but there is a form or formula that allows us to find the coefficient of a binomial when we get into specific locations. Maybe we don't need the whole row of the coefficients. We only need a specific one. And what that is n over r equals n factorial over r factorial times the n minus r factorial. Now, this item goes with a different one, and we are not doing that in this course. So let's just focus on this one right here. Whatever the n is, it will be n factorial on top, r factorial, and then the subtraction of those two on the bottom as well. So if I give you an item that said, let's calculate the binomial of the expression, and it is 9 over 4. Well, the 9 is the n. It's the nth position. So that's the total amount of terms that are in the row, and the 4 means the position it's in. So the fourth one down. Just like up here, let me just scoot this up. This would be your n is 7, and I would want the fourth one in. So I would have 7 over 4. And then my binomial coefficient starts off at 35. So that's what this means. So I would have 9 factorial over 4 factorial, and then 9 minus 4 factorial. Now I know that most of our calculators will do it for us, but you need to understand where this comes from, how it's found, and show some handwork for it. So with that, I have 9 factorial is the same as going from 9 down to 1. Or you can go 1 up to 9. It doesn't matter. So it's either 9 times 8 times 7 times 6 all the way down, or you can state it as 1 times 2 times 3 all the way up to 9. Doesn't matter which direction. Maybe I'll just do low to high this time. So 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. That's all over these two pieces being multiplied. Well, 4 factorial is 1 times 2 times 3 times 4, or go from 4 down to 1. And then this item right here, this truly is 5 factorial in the end. So I go, oh, okay, that would be being multiplied by 1 times 2 times 3 times 4 times 5, or backwards, 5 times 4 times 3. It's typically 5 to 1, but I don't care which way you go. And then I can easily go, oh, well, I can reduce anything divided by itself as 1, because it's all being multiplied. It's all multiplication, so I can reduce before I multiply. I know 5 divided by 5 is good. I know 6 can be divided by 2 times 3, which is 6. You can do that. And then I also know 8 divided by 4 is 2. Now, you don't have to do it all the way down. It's just an option. And then I would highlight, okay, what do I have left? I have 7, 2, 9, all over 1. So I have 7 times 2 times 9 all over 1, which is 126. That is the coefficient that would go in front of the position. So this would be 9 terms, and this is the fourth position. What is the coefficient? It's going to be 129, or excuse me, 126. Now, what if we have it even larger? So we do 197. Ooh, what is that? Well, this is 100 factorial over 97 factorial times 100 minus 97 factorial, which we already know this would be 3 factorial. I'm not writing 100 numbers out, but what we can show, and maybe I'll go from high to low this time. A lot of professors will start with the high and go down to the low. So I would say at least show to whatever this number is down here, 97. I would have 100 times 99 times 98 times 97, dot, 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 and maybe I'll go, because this is a 3, down to 3 times 2 times 1. Then I don't have to state them all. I know that this goes from 100 to 1, or you could have gone the other direction, 1 to 100. It doesn't matter. All over this of 97, so I would have, oh, okay, 1 times 2 times 3, dot, 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 all the way to times 97. Times we have 3 factorial left. I went the other direction, sorry. So 3 times 2 times 1. Maybe I'll go that direction again. Okay. Well, let's look at what this is. This is, let me rewrite that so we keep it in the same order. So this would be from 97, dot, 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 down to 3 times 2 times 1. It goes all the way from 1 to 97 or 97 to 1. And I go, okay, before I multiply anything, let's get rid of some. Well, isn't this the same as going from 97 to 1 here? Absolutely. So anything divided by itself is 1. And if you don't want to do any more reducing, then all you have left is 100 times 99 times 98 over 3 times 2 times 1. Make sure that you plug this in. If you're going to plug it in as one item, that you put this in one parenthesis and this in another parenthesis. Otherwise, you'll get a different answer in the end. The coefficient in the end is 161,700. I would not want to be doing Pascal's triangle to do a row of in power of 99 or 100 or 105. I would hate to do that. So that gives you an idea of how to find a specific coefficient in a binomial without actually doing the whole thing.